So topic for today is energy storage system for charging stations. As you know, electric vehicles are day by day going to come into the market. There will be demand of charging stations as well as there will be demand of energy, that is electricity. So basically, and there are various energy storage systems, but in this video, in this presentation, I'll tell you about energy storage systems which will help electric grid, especially for charging stations. Okay, this is energy storage system classifications: electrochemical storages, that is batteries; electromechanical storages, that is flywheels; electrostatic storages, that is ultracapacitors; and hybrid, that can be combination of any of above. Other than these, there are also storage systems like pumped hydro storage systems, compressed air, etc., etc. But in my opinion, when we go with support for electric grid, especially for charging stations of EVs, these are the three main energy storage systems which will help charging stations. So that is why I am talking only this. Okay, let us see one by one. First is electrochemical storages, that is batteries, which has generally higher energy density but power density is little bit low. Its drawback is very poor performance, lifetime is degrading, with the situation, a number of cycles, as well as temperature based, depends on the conditions like how we are operating, what is its depth of discharge, state of charge, with respect to the temperature, whether rusting is there or not. So generally it is 100 to 1000 cycles. Okay, and that also depends on type of battery, the material used, the electrodes used, electrolysis, what kind of electrolysis are there. Okay, so it depends on type of battery. There is electromechanical storage systems also, that is flywheel. The best thing in flywheel is frequent charging and discharging does not affect life cycle. Okay, and the power density is 5 to 10 times more than the batteries. In case of batteries, we have lower power density, but in case of flywheel, it goes 5 to 10 times more than the batteries. Of course, there are disadvantages, that is time of reply to fast variation of required power. Okay, so there is very slow response. Second is proportional to the inertia of the system. Okay, generally energy is 1/2 I omega square, where I is moment of inertia, I and omega is angular velocity, and the gradient of power in time is very high. So that is the difference. But flywheel can be utilized for slow charging, especially to compensate some load shedding issues, and you can have your valley filling concepts, especially in power system, through flywheels. There is another, that is electrostatic storages, which is known as ultracapacitors or supercapacitors. It has high power density but lower energy density. They are very fast in charging and discharging both, longer service life and higher efficiency. The disadvantage at present is ultracapacitors are costly, but that is very helpful in case of you have a combination of ultracapacitor and batteries for fast charging, and you can have different control mechanisms so that you can do better charging. Fine. And the most important, and as per the technology, that is hybrid storage system, which can be the combination of any above which we had talked, that is battery, flywheel, ultracapacitors. And you can have separate hybrid storage houses, and that is based on grid as well as based on electric vehicle, the location of the charging stations. Okay, and that is the huge picture which is going to change the whole scenario. Okay, let us go in the batteries available in the market, and there are some specifications to understand. Type of batteries like lead acid, which has efficiency up to 70 to 80 percentage. Energy density is 20 to 35 only. Power density is also 25 only, and life cycle is 300 cycles. If you want to understand what is energy density, power density, and what are the life cycles, what is depth of discharge, etc., there is another video in my channel you can see, that is the battery technology and its parameter. Another battery is nickel cadmium, which has 60% efficiency, 40 to 60% energy density, 140 power density, while life cycle is 2000. Nickel metal hydride, which has 50 to 80% energy efficiency and 60 to 80 density, that is energy density, 220, that is power density, and life cycle is very less, that is only 200. Generally you might have seen this nickel metal hybrid during the digital camera era. Lithium ion is 85 to 95% energy efficiency. The energy density is 100 to 200, power density is 300 to 2000, and life cycle is 5000. Okay, the range for energy density 100 200 and power density 300 2000, that depends from manufacturer to manufacturer, as well as the size, the potential and AH. Okay, lithium polymer, that is 80 to 90 percentage of energy efficiency, 25 to 75 only, that is energy density, but power density is 500 to 20,000, and the life cycle is almost 12,000. Yeah, of course there are reasons why we have less number of cycles in nickel metal hydride, and why this lead acid is having lower energy density and power energy density, 20 to 35 and 20 25. So basically some countries, like developed countries, they prefer lithium ion, but in some developing countries, they still prefer lead acid batteries or VRLA system kind of batteries, which has though less cycle, number of life cycles, but the cost is very less. Okay, now main thing is, what are the major challenges for EV charging, and why I had chosen this topic, that energy storage system, and that is for charging stations of EV. So major challenges are charging time, as you know, peak power demand, and power quality issues. Okay, so briefly I'll tell you, the probable solutions for this. For peak power demand issues, as per the need of the grid, energy storage system is to be integrated. Hybridization is required to get the lesser charging time along with electrical stress on the grid based on the power demand and reduced power quality issues. So basically, to reduce this electrical stress on the grid, you can have the combination of ESS, maybe flywheel plus battery, maybe battery plus capacitor. Okay, and that is the solution for reducing the charging time is electrical energy suppliers should fix the zones and time. That means geographically and peak load based energy bill, so that the peak demand will be reduced and the stress on the grid as well as power quality issues can be handled. Okay, for power quality issues, especially less number of converters and energy exchange with standard converters are required. Time based charging methods can be operated, and can be motivated to use battery swapping stations more and more, and based on ultracapacitors and flywheel based technology. So let us hope in coming future we have the perfect solution for peak power demand, charging time, and power quality issues. If you have any question related to this video, you can drop into the comment. Thank you.